I'm Neil Gershenfeld. I direct Center for Bits and Atoms. I run a lab some of you have visited where we have tools to make almost anything of any size. And when the pandemic were hit, we got a lot of questions and requests for how we can help. At that moment, there were tons of labs making ventilators and DIY making shields, and it wasn't clear those were useful. So I started a working group to look at research for rapid prototyping on the pandemic. One of the most interesting results, it grew into a few hundred people from government, healthcare, industry, activists, all sorts of people who had never worked together and didn't think they would want to work together or be interested, and found they could really collaborate. And so coming out of that, some of the things we started with molecular modeling of virus propagation, CFD, of nanoparticle flows that led to processes for producing filter media and swabs, nanoparticle testing of then filter media. We found significant leakage around DIY shields that led to curve crease folding and eliminating the need for printing and the need for protecting frontline workers with isolation boxes, not just PPE, need to help visualization for things like ventilators to know what's going on in them, improved UVC sterilization. All of these are easy to reproduce, but a lot of research was needed to work out the processes for them. These events I've shown here talk more about that stage. As that matured, then the question was scaling. There was a gap between DIY one-off and mass manufacturing. One way we dealt with that was new business creation. So a few startups were spun off. This was an interesting one Matt Carney led to make a very high efficiency reusable mask based on the CFD modeling and the nanoparticle tracing, Open Standard Industries. And then a really interesting one was, this was a project from Maker Asylum in Mumbai, where they coordinated PPE production in India as a distributed production systems, vetted designs in the way I'm describing, propagated them across labs across India, and then we're producing PPE in the millions in this kind of scalable distributed way, and progressed from there to currently working on oxygen concentrators. And so all of these help fill in this gap between one-off DIY and volume scaling, and help bridge between fairly basic research and things like virus propagation and CFD and molecular modeling, and deployment at scales to help with the pandemic. Then as this progressed, one of the things I ran into is at both MIT and through the FabLab Network, one of the things I teach is rapid prototyping classes. The FabLab Network has grown to right now about 2,000 labs in 125 countries. And then we fell off a cliff because students couldn't come into labs. And so how do we continue teaching hands-on classes without the ability to get to a lab? And so what that accelerated was rapid prototyping of rapid prototyping. So this was an example of a machine one of my students, Jake Reed, developed, aimed at very high resolution precision machining, aimed at making surface mount electronics and molding and casting, that we then did quick turn production in my lab and send out to students. With colleagues at Shenzhen from Seed, we put together a surface mount rework briefcase. This was an immersive VR lab. This was a remote interface to lab machines. And what all of this let us do was, instead of in the pandemic bringing students in the lab, we could push the lab out to students. Something we had talked about for years, but we were able to do with the pandemic. And as now we move towards reopening, we're finding this blending of, rather than being rate limited by these scarce resources, by bringing labs to students, are letting us use the much more expensive tools selectively centrally and propagate these in a distributed way. And so in the same way computing scaled 1,000 million, billion, trillion, the research in my lab has been running through a roadmap from the 1952 NC mill that there was one of at MIT, to thousands of fab labs, to machines making machines, to assemblers and self-assemblers. We're working on all of these in parallel, but when they come out is staggered in many years, like the scaling of computing. And the stage of not needing to go to a lab to make something, but needing to go to the lab to make the thing that makes something, the rapid prototyping of rapid prototyping, we had still seen as years in the future. And the pressure of the pandemic has really accelerated the ability to do rapid prototyping of rapid prototyping, so viral spread of the machines themselves. And ultimately what that's leading to is an idea, a sense of building back better. So the pandemic led to dire issues in failure of supply chains, in businesses failing, in unemployment. And a lot of that assumed global supply chains to source needs, and a sort of a tautology that jobs equals work equals money equals consumption. If you have access to these means to make while being connected globally, it's not utopia, it's not free, but the ability to produce locally fundamentally changes those assumptions. And so it's a kind of a back to the future with sustainable local production, but rest on global knowledge and covering what you need to make a technological society. And so these articles and books talk about this shift from equating jobs equals work equals money to sustainable local production. And in particular, at that moment we're at right now, rather than waiting 50 years for the equivalent of spam and fake news and income inequality that happened in the first two digital revolutions, how we can shape this one today to be more diverse and equitable and inclusive. So all of this was things heading for the future. The pandemic urgently needed them, and in turn demonstrated the viability of really doing this at large scales, really making an impact on how economies work, and pointed to the possibility of continuing this. And so if you're interested, once a year, this global network gathers. It's coming up, hosted in Montreal, but now distributed. And one of the most interesting parts is many, if not now, most of the leading cities of the world have joined a Fab City initiative aiming at providing the means to make as part of urban infrastructure. And instead of products going in and trash going out, data comes and goes, but atoms stay and get manufactured and remanufactured. And so again, you don't need an economy for money for work, but really changing fundamental assumptions about how you live, learn, work, and play in a world where anybody can make almost anything. Those of you who know me know that those have been ideas over a many-year arc. They were urgently needed during the pandemic. The pandemic helped show the viability and has really accelerated the arrival of all of these trends. So with that, thank you.